Hello, everyone. I hope you're having a great time at reInvent. I know it's 5:30, and everyone must be really, really tired. I can see a few familiar faces. By show of hands, how many of you have used a data warehouse before? Oh, well, you're in the right session then. That's a good thing. And how many of you are planning to modernize your data warehouse or are currently in the process of doing so? Oh, that is great. You guys really picked the right session. We are very sorry that this session is at 5:30. We wanted to make sure that you're bright and shiny and fresh in the morning, but unfortunately, this is the session we got. So, my name is Raza Hafiz, and I'm a senior product manager with Amazon Redshift. I'm responsible for creating new features in Amazon Redshift. Today, with me, I have Sebastian Harold from Zalando and Ravi Thadisetti from ADP. And we're going to walk you through how customers like you can modernize your data warehouse using the power of Amazon Redshift to get business value. We're going to give you a quick and comprehensive overview of AWS Analytics to begin with, as well as Amazon Redshift. Then we're going to cover some key feature announcements that we've made in Amazon Redshift and AWS Analytics, highlighting some of the innovations that we've done. Then we're going to cover some real-world use cases of how customers like you can use Amazon Redshift to power your business. Then we're going to come to the really exciting piece of this presentation where Sebastian is going to tell us how Zalando modernized their data warehouse using the power of Amazon Redshift. And Ravi is going to walk us through the transformation journey of how ADP used Amazon Redshift to modernize their analytics stack. So let's jump into it. Data is at the heart of every business process and drives critical business decisions. Are everyone with me here? Any conflicts about the importance of data? That's great. So it also becomes a foundation for digital transformations for multiple organizations. Data has also become a critical building block for generative AI. Customers are using generative AI to power their data models, and your data models are only as good as the data foundation underneath. So having a strong data foundation is critical for business, for generative AI. How many of you have heard the phrase, data is the new oil? I thought so. Let me rephrase that slightly. Data is the new generative AI differentiator. Patented. Customers like you are using generative AI to power use cases like chatbots, summarization, sentiment analysis, just to name a few. And I recently came across a study which said 97% of executives said that generative AI is going to transform their industry. And 67% of organizations said that they'll increase spending on generative AI and data. But harnessing the power of data still remains a challenge. Another study from Accenture said that only 32% of organizations are able to get value from their data. This is because data systems are siloed, complex, and sprawling. The data is spread across the data warehouse, the data lake, the operational data sources, and many more like on-premise systems or SaaS applications. Who here has asked their IT administrator, hey, where did the data come from? It doesn't look good, right? That's a question that everyone has in their mind. And then once you get the data, the next question you ask is, who has access to this data, right? Because it's all over the place. So governing your data becomes a challenge as well. That's where AWS Analytics comes in. AWS Analytics gives you an end-to-end data strategy. And you can ingest data from multiple different sources, process it, analyze it, and find game-changing insights using the power of purpose-built data stores or the analytics tool of your choice, whether it's Spark, SQL, AI, ML, or generative AI. AWS Analytics also gives you a comprehensive security and governance framework. So your data is secure from end to end. Customers like you are using the power of AWS Analytics to power their business and grow as quickly as possible. Who here heard the new announcement about the next generation of Amazon SageMaker from Matt? Do I really need to tell you more about the presentation here? So the next generation of Amazon SageMaker is a unified platform that unifies your data, analytics, and AI. You can collaborate faster and build solutions quicker using the unified studio, using familiar tools of AWS like Amazon Redshift, Amazon S3, etc. You can also reduce silos using the open lakehouse. And this allows you to access all your data, not just the ones in your data warehouse any longer. You can access all your data. And we need to make sure that every piece of your data is secure and governed end-to-end. That's what the next generation of Amazon SageMaker allows you to do. Within the next generation of Amazon SageMaker, Amazon Redshift is our most price-performant SQL engine. Working as tens of thousands of customers like you are using Amazon Redshift to consolidate their structured and unstructured data from terabytes to petabytes and analyzing this data at scale. Working backwards from your requirements, what we've done, we've been innovating in a few key areas. If you look at the center of the slide, you can see we introduced the multi-warehouse architecture using data sharing. This allows you to share your data across your organization seamlessly and securely. It also helps you do workload isolation so that you have less resource contention, which makes Redshift scalable, performant, and cost-effective. Also within the center of the slide, you can see that Amazon Redshift gives you the ability to store your data in analytics-optimized columnar format for high query performance, as well as open table formats like Apache Iceberg, so that you can analyze all your data. Coming to the left, we introduced features like zero ETL and autocopy that eliminate the need for you to create and manage complex data pipelines to ingest data from sources like operational data sources and Amazon S3. How many people of you here have just wondered, hey, how do I get this data into my data warehouse just so I can analyze it, right? That's an issue that most customers have these days. But with these features, we're trying to make it seamless for you to be able to analyze the data as quickly as possible and not having to do anything with the ingestion pipelines. Coming to the right of the slide, you can see Amazon Redshift allows you to analyze your data in an analytical style of your need. We have business developers, we have engineers. All of these people can use their data using SQL, Spark, or even AI, ML, or generative AI to power their workloads. And Amazon Redshift gives you the flexibility to do so. All of this has been possible because we've been innovating in a few key areas. The first area is price, performance, scalability, and security. And in this area, we launched data sharing reads a couple of years ago. And this year, we launched data sharing writes. This allows you to distribute your workload throughout multiple Redshift data warehouses and not only read, but also write data through other compute clusters. We also enhanced autonomics and workload management. So customers like you don't have to worry about tuning their workload. And we take this away from you, and we do the heavy lifting for you. The next thing that we worked on was SQL across the data lake and Redshift. We wanted to make it seamless so that customers like you can access all your data, not just the data sitting in Redshift, using the analytical tool of your choice, whether it's SQL or Spark. We wanted to streamline ingestion for you by introducing features like zero ETL, autocopy, and streaming ingestion so you can analyze your data as soon as the data lands in Amazon Redshift in near real time. And we wanted to simplify the data analytics workloads by introducing AI-driven scaling in Amazon Serverless so that you don't have to worry about resource management or we also broadened the compute capacity of Amazon Serverless, so you can use Amazon Serverless for a broader range of workloads. Lastly, we wanted to integrate Amazon Redshift with generative AI. So customers like you can use the power of generative AI in your analytics workloads. We integrated it first with Amazon Bedrock, and also Query Editor V2 features Amazon Q, which you can use to ask questions in natural language and have that automatically be converted into SQL. No longer do you have to write complex SQL. You can be like, hey, show me the data for the past year, sliced by this dimension, and for this data range. And Amazon Redshift gives you that data. All of this innovation has made it possible for customers to use Amazon Redshift in a broad variety of use cases other than the traditional business intelligence and reporting use cases. Customers are using Amazon Redshift to build modern data architectures with self-service capabilities. They're using Amazon Redshift to create data sharing architectures, whether it's hub and spoke or data mesh, so that you can spread your workload across multiple Redshift clusters. They're using near real-time ingestion so that you can get analytics from your data as soon as the data lands in Amazon Redshift. And we wanted to make sure that you can analyze all your data. We don't want to have multiple copies of the data. We want one copy of the data and accessible to you as soon as the data is available. So using the power of Amazon Redshift, you can query across the data lake, Redshift, and operational data sources without a problem. Next, I wanted to cover a use case of how customers are using Amazon Redshift to power their business. The first use case is an enterprise business intelligence and reporting use case at Hilton. I'm pretty sure that everyone's heard about Hilton, right? Yeah, I'll take that as a yes. Hilton migrated to Amazon Redshift in 2017 and then decided to modernize their architecture in 2023. They wanted to consolidate their data from multiple different properties all over the world. They wanted to make sure they analyze this data, process it, and find insights when it came to room booking and customer experience. So they used a data sharing architecture powered by Redshift Serverless, and they used a multi-warehouse architecture using Amazon Serverless and data sharing. Using this architecture, Hilton was able to meet all of their business SLAs because they spread their workload across multiple Redshift clusters. Also, this architecture allowed them to cater to the needs of 22,000 active users. Think about it for a second. 22,000 active users running queries against your data at the same time. This architecture also scaled so that if customers needed to be added, they could easily be added, and as workload changed, the architecture would scale, which allowed Hilton to add 2,000 users per month to their architecture. Using this architecture, Hilton was able to consolidate their data from different properties, find insights about their customer experience, and optimize their operations. Next, I'd like to cover a near real-time use case, analytics use case at EchoStar. If you haven't heard about EchoStar, that's fine. EchoStar is the parent company of satellite TV providers like Dish Network. EchoStar was ingesting data from 150 Amazon managed streaming for Apache Kafka topics. They were ingesting 10 terabytes of data every single day. With this, the biggest problem is how do you make sure that your workload scales and operates within the SLAs? EchoStar also employed a multi-warehouse architecture using Amazon Redshift, Redshift Serverless, and data sharing. But prior to moving to this architecture, the ingestion latency to just ingest this data was between 2 to 3 days. And after migrating to this architecture, their ingestion latency became 37 seconds. That's the power of Amazon Redshift that customers are unlocking. Also, using this architecture, If you have data about your users in 37 seconds, imagine for a TV provider, you can actually show them targeted ads and unlock opportunities that were previously just unimaginable. That's the power of Amazon Redshift. Lastly, I'd like to cover a generative AI chatbot use case. I'm sorry, folks, we can't talk about data these days without talking about generative AI. Our solution architecture team came up with an architecture that you can see on the screen. This architecture actually uses, takes in user input like the user ID, username, and then passes this information to Amazon Redshift. Amazon Redshift stores a comprehensive version of the data for each user, like their name, their address, their age, their hobbies, their past and future travel itineraries. And Redshifts collected all of this data from multiple different sources like the operational data store or data lake and from within Amazon Redshift. Once this data is brought into Amazon Redshift, it is then transmitted to Amazon Bedrock using the new integration with Amazon Bedrock. And the Anthropic Claude large language model uses the data housed in Amazon Redshift to create personalized travel itineraries for this user depending on their interests and their hobbies. Let me show you a quick demo about this use case. So first, we'll start with the AWS console. I'm pretty sure everyone's familiar with that. We'll go to Amazon Bedrock, and then from here, we'll make sure that the Anthropic Claude large language model is enabled in the region. Next, we'll go back to the AWS console and go to Amazon Redshift. Here you can see we already have an Amazon Redshift serverless cluster available, and we're going to query the data within the serverless cluster using Query Editor v2. Here, I'm going to connect to the Amazon Redshift cluster, and within this cluster, you can see the data has been brought in through zero ETL from sources like Aurora or RDS. We have two tables here. One table is related to a user profile, and the other table is related to the hotel booking. Let's query the user profile data for a particular use case. This user, his name is Santiago. He's 45 years old. He likes scrapbooking and pineapple buns. I don't know what pineapple buns are. If anyone knows, please let me know. I'd like to know. Thank you. Then we'll look at the hotel booking table and query for the same user, and we can see Santiago has an upcoming trip to Thailand. Now, using the same user ID, what we're going to do is we're going to go into Cloud9, where we've already initialized the application, and put in the username, the user ID. On the left, you can see a query has been run against Amazon Redshift. This query is collecting critical data about this particular user and passing it on to Bedrock, so that Bedrock is aware of who this user is and what the user is going, where the user is going. And then, using the power of natural language, we can start asking questions like, hey, tell me something to do on my upcoming trip. And you can see on the left, the prompt actually has data from Amazon Redshift, and it's able to generate a response using that data that Santiago is going to Thailand, and depending on his use cases, these are the things that Santiago might like to do. Next, we can refine these searches and say, hey, tell me about the weather on my upcoming trip, right? And using the power of Redshift and the data housed in Redshift, Amazon Bedrock is able to reply and tell you, hey, make sure to put on some sunscreen because it's going to be hot. I covered a few use cases of how customers are using the power of Amazon Redshift. We covered things from traditional business intelligence and reporting use cases, all the way to modern chatbots using the power of Amazon Redshift. Now, just for a second, think of all the use cases that you can solve in your organization using the power of Amazon Redshift. On that note, I would like to invite Sebastian from Zalando to tell us how Zalando used the power of Amazon Redshift to modernize their data ecosystem. Thank you.
Thanks, Vada. Happy to take it from here. Yeah. My name is Sebastian Harold. I work as a senior principal data engineer at Zalando in the central data platform department, and I'm happy to tell you about our journey with Amazon Redshift to innovate our fast serving layer. So first question, who's Zalando? So in the US, almost nobody knows Zalando. In Europe, we are the leading multi-brand fashion destination, and we are in more than 20 countries, so we are kind of the Amazon for fashion in Europe. So we have more than 50 million active customers and make more than 14 billion in GMV. So to provide this fashion experience at scale, we understood that we need to be a tech company. And this means that all operations are fueled by data and AI. So we use data and AI for size recommendations to reduce the return rate, for the perfect pricing, for forecasting, for logistics, marketing, content selection, user selection for our campaigns, and of course, fraud. And because we understood that data is so important for our business, Zalando has a big data mesh platform. So who has heard about data mesh? Okay, that's good. So there are actually 4 key components of a data mesh. And in the center of the data mesh, for us, there are the data products, because this is how you generate value out of data with the data products. So they are in the center and surrounded by decentral domains. So we have the data team sitting in the domains because they're the experts and they know the knowledge about the specific domains. We have computational governance to make it easy to work with data. And of course, we have the self-service platform where all the data products live. And if you zoom in and see what the self-service data platform consists of, you see there's SQL access to data, there's reporting, dashboarding, transformation, orchestration, discovery to find the data. We measure quality or make it easy for you to measure the quality of your data, and much more like education, training, these kind of things. And when you see how the data platform is adopted, and you see we have more than 6,000 monthly active users on our platform, which makes more than 80% of our corporate employees. You see data is really crucial for us. We have more than 20 petabyte of data in our data lake, mostly in Delta format, and we have about 5,000 data products which are owned by 350 teams across all business units. The fast serving layer, and this is what I will talk about here, is the key component to get fast SQL access for our main data sets. So there are about 5,000 tables and views that are mainly used for all the analytics and ML. But of course, we have much more data. That's why we kind of provide these 5,000 tables in the fast serving layer to serve the dashboards and reports for more than 3,000 people every week. And it's also used for ad hoc analysis because it's super fast. Yeah? So this is about 300 terabyte of internal storage, and we mainly load the data from S3 and also export it to S3 sometimes. But it's not a classical data warehouse. We don't have much ETL on the fast serving layer. They're just simple business units and transformations. But it's mainly used for select queries. So what is the problem? Currently, we have a big monolith and a huge cluster running the fast serving layer. But the problem is that the scaling of the cluster is optimized for a few peak loads during the week. On Monday morning, for example, there are weekly jobs, there are daily jobs. So on Monday morning, there's a huge peak, but there are also some other peaks during the week. And the cluster size is optimized to handle these peaks. But in 80% of the time, the cluster is idling. So we are wasting compute because the technology we are currently using does not allow us to scale dynamically the cluster. So we're wasting a lot of money. This was one of the key drivers. Also, what we found is that in our post-Oracle era, so because this fast serving layer was tightly connected to our Oracle data warehouse, but this is already decommissioned, it is super crucial to efficiently load and unload data to S3. And the current technology only allows us to export CSV really efficiently, which is not great. If you want to use Parquet, it gets super slow and resource consumptive. So what we found is that, do we really want to have this fast serving layer like it is today in 2 or 3 years? And we said, no, I think we lack some future readiness here. Yeah? So there was also no online query editor, no GenAI assistant. We had a session limit of 100. We lack isolation, so there could be one analyst running a heavy query, which could bring down critical reporting. And also, we reached the limits of horizontal scalability. So we ask our vendors, and of course also Amazon, to help us with the problem. And we did several proof of concept, and one with Amazon Redshift. And it was really, really promising. So what we wanted to do is we wanted to separate the data producer from the data consumers. So we set up 2 instances, one producer instance and one consumer instance, which are connected via data shares. And then we did the performance testing with Apache JMeter. And the outcome was that perfect, right? So this multi-instance architecture gives us a lot of flexibility. And the performance test that we did with some light and heavy queries turned out that Redshift is significantly faster than our current cluster. So when you see the numbers, about 16% of the queries were more than 20x faster than on the previous system. About 44% are more than 2 times faster. And of course, some queries were slower, but it's okay. It was only about 8%. So our estimation was that the overall execution time for this Monday morning load would drop by 3x. And which is important also for dashboarding and reporting is that Redshift excels especially on light queries, so you have fast feedback for your dashboards and reports. So we had great support. What I need to say here is we had great support by AWS professional services and experts. Some of them are also in the room. So this helped us to speed up the POC and do the optimizations to have these great results. So we decided to move on with Amazon Redshift, and our target architecture would look like this. So we wanted to isolate use cases by cluster or instance and fan out the use cases and clusters by data shares between them. So the data loading API shall be used to load the data from S3, from several distributed S3 buckets, to the producer cluster. Why do we have a data loading API here? We see there is a lot of improvement now, and when you have seen the announcements today, so where you can use the Iceberg REST API to ingest data, we want to make use of this. And the data loading API is the abstraction for the users to just say, I have this S3 data set, and I want to have it loaded into a certain table. And we take care of all the details behind the scenes. So whenever there is a new feature or new announcement, we could just build it into the data loading API, and there's no change needed for our users, so we can continuously benefit from the features that are upcoming. And on the other side, the consumers can be specific for each use case, yeah? For different BI tools, for analysts, for talk reporting. And we can easily fan out more consumers because they are all connected through the data shares, which is and you don't see a performance penalty here. And what we also found is that we want to use Redshift serverless wherever possible because this gives us the perfect price-performance ratio that we want to have. So how does the migration look like? So when you zoom in a little bit to our previous system, you will see there's kind of a source layer where the data is loaded into, and then there's some scripting, some ETL, some views. And the presentation layer is actually the layer that is used by the applications and the human users, the analysts using the system. And what we found is that we want to set up the presentation layer also in the new cluster. And then use consumer clusters, which are connected via data shares, to also have the presentation layer ready to be used by the users. So what we came up with is, in the first phase, we wanted to synchronize the data with, we call it Change Hub, which is just generated Airflow decks out of a configuration, which are running on MWAA. And we used change data capture based on timestamp columns, partitions, or sometimes even full loads if the table is not big, for example. So we could replicate the presentation layer easily to the new Redshift cluster and are able to parallelize the work during the migration. We could migrate the consumers of the data at the same time as the producers of the data. Yeah, so this was a huge speed benefit, so we could parallelize all the work. In phase 2, we started migrating the first applications and the first users to use the new systems. Because the presentation layer was consistent between the old and the new world, this was easily possible. And then we also set up the data loading API, which allowed the first data producers to load the data into Redshift the new way. So we could work with some consultants internally with each of the team to migrate, be it consumers or be it data producers. And in the third phase, when all the applications and all the users are migrated, we could just decommission the Change Hub, switch it off, and then decommission the system. Okay. Currently, we are almost done with phase 3, so it will take us maybe 3 or 4 more months. But I would like to share some learnings that we had so far. We had to migrate or translate more than 5,000 SQL queries. And what we found is that most of them, 80%, can be translated automatically because they are simple or use LLMs or whatever. So this was really super fast. What was annoying were the remaining 20%. They contained Lua scripts and other complex stuff that is not easily transferable to Redshift. And these scripts took us months to translate. So this is something to consider if you do your migration. Be aware how complex are your queries, how many of them can be translated automatically. If it's a lot, then it makes the transformation much more easy. At the same time, we found that Amazon Redshift Serverless is an excellent default option. So if I would start from scratch, I would always use Redshift Serverless. And only for some special cases that we had, we needed fine-grained workload management. And therefore, we used provision clusters. They offer more fine-grained workload management. But Amazon Redshift Serverless is our default. Also, what we saw is that because we have a lot of Delta format data sets in our data lake, it's a little bit tricky to implement incremental loading into Redshift. But this is all covered in the data loading API. So if we would switch to Iceberg or whatever, the data producers wouldn't need to change anything, and we will make use of it. But if you want to incrementally load Delta format, you need some workarounds. What we also saw is that now we had an online query editor for Redshift, and people loved it. Yeah? And I'm also curious to see when the new SageMaker Unified Studio will come up, how this will be adopted, because I think it's even more increasing the user experience. The only downside, what we also saw is that because we have so many workloads on the consumers, currently when you use data shares, they are not influencing the automatic optimization on the producer cluster. So it needed some manual tuning here, and AWS also helped us a lot here and is still helping us to optimize it. But we are working with AWS to improve the situation, and I think this will be coming soon. Okay, so we are live since October, or the end of October, and so we don't have much experience yet. But what I can share is that we already see that 76% of the queries run faster on Redshift, which is huge. Yeah? So this saved us more than 1 hour in report availability every morning, and also reduced our monthly cost. We don't have the final numbers yet, but we expect a 2-digit percentage in the monthly cost. And when you see this from an operational perspective, we are now much better able to deal with different load situations, because we could just easily scale up the clusters and scale them down if we don't need them. And here I also have a picture from the MicroStrategy job queue. Before, the queue was really, really long and didn't decrease fast. And now with Redshift, you see how the job queue is decreasing super fast, and the dashboards and reports are available really fast in the morning. So what is the outlook? We are not done yet. So what we want to do is we want to use lake formation, yeah, for centralizing the data access between the clusters. This is super cool because currently we need to handle the data access on each cluster and instance individually. With lake formation sitting in the middle, you can steer the data access really perfectly, also connected to the Google catalog. Also, we have Redshift clusters existing in the company, and we want to connect these clusters also to our central infrastructure via data shares. Yeah? Said that writable data shares is in preview. So this will be a super interesting feature for us, so that we can offer data shares to the existing clusters, they write the data into it, and it's automatically available on our central infrastructure. And like I said, so serverless shall be the default. So we try to convert all the provision clusters to serverless environments in 2025. And with this, because we also believe in Redshift, we want to offer Redshift as a service internally. So kind of as a package that more and more use cases can easily adopt, which then includes standards for authentication, data access, data sharing, connecting to the central platform, optimizations, and data ops. That's it from my side. And now I'm handing over to Ravi from ADP, and he will tell you about their journey with Amazon Redshift.
All right. Thanks, Sebastian. Hello, everyone. My name is Ravi Tadisetti, and I'm Vice President at ADP, responsible for analytics application product engineering. Happy to be here to share some of the learnings and highlights from our Redshift migration journey. So a quick introduction about ADP. Some of you may know ADP as a payroll company. Today, ADP is a global leader and largest provider of human capital management solutions in the industry. Our comprehensive products offer innovative solutions in HR, payroll, benefits, time, compensation, and many more. We serve a range of companies from small businesses to very large multinational corporations, including Amazon. Today, we serve over 1 million clients across 140 countries. In the US, we do payroll for 1 in 6 Americans. That's about 20 million employees, and 40 million worldwide. So there's a good chance some of your payroll is also done through ADP's payroll systems. As you can imagine, we have an incredible wealth of data, and we can generate amazing insights for our customers. So that brings me to ADP Analytics, the application I am responsible for. This is also called Data Cloud. ADP Analytics is the people analytics offering for our HCM customers. Over 50,000 customers use this product, The primary users are HR, payroll, benefits practitioners, and managers. The application offers insights to our customer data. Through 100+ metrics, KPIs, and storyboards, the product offers easy-to-consume analytics in a Q&A format. It answers questions in a range of topics from cost of turnover, overtime, pay equity, diversity, and many more. For example, which locations are trending higher on turnover, or which departments are trending higher. So all this analytics is powered by technology and data warehouses hosted on our on-prem data center. We started our journey about 10 years ago with a few hundred clients. Over the years, the product grew rapidly, and with rapid growth came many challenges. As you can imagine, our primary challenges are around scalability and performance. As the clients grew and the data grew, the performance of our workload started degrading to the point we started missing our SLAs. We could add more databases or upgrade databases, but as you know, hardware procurement cycles are long and expensive. As we start selling the product in new regions, we had to build out new environments and deploy the application in new data centers. That also takes significant effort. So to address these concerns, we made a decision to migrate our data warehouse and the entire application to cloud. So our journey to cloud started with an evaluation of top 3 data warehousing products. That includes Redshift, of course. While we had many requirements for data warehousing, 3 requirements stand out. Our top 3 requirements are scalability, performance, and multi-tenancy. I'll talk more about these in detail. So after detailed evaluation, we found that, honestly, none of the 3 products met our expectations. Amazon Redshift came closest to meeting our expectation on scalability, and the Redshift team and the solution architects actually assured us to solve for performance and multi-tenancy requirements. So we went with Redshift. So the migration to cloud also gave us opportunity to simplify and streamline the architecture and introduce new capabilities for our customers. If you look at the architecture, on the left-hand side, we have OLTP systems replicating data to S3. We built ETL pipelines to transform the data to star schema and load to Redshift. And on the right-hand side, you see our consumers, including analytics application. Now, I'd like to draw your attention to the ETL pipelines. In the on-prem data center, our ETL used to run for 10 to 12 hours overnight. So the customers used to see the previous day's data. So data freshness was one of our complaints. In the cloud, we are able to run that ETL within an hour. So we are able to run ETL multiple times throughout the day, so customers see fresh data. So we solved the data freshness problem. Now I'll talk more about scalability and performance. First, let me share the nature of the workload our application provides and the performance expectations. Our application is offered on web and mobile, so you can imagine we have very demanding SLAs for performance. Our 95th percentile is 3 seconds, and average response time is sub-seconds. During peak loads, several thousand customers use the product, and it generates almost 500,000 SQLs an hour. So it's essentially a high concurrency, low latency kind of workload. The workload varies throughout the day. You can see the load pattern graph. The peak load is 3 times the off-peak load. We are able to achieve almost sub-second response times throughout the day. So how did we achieve these results? So I'll share some of the details that we did. First and foremost, the cluster configuration plays a significant role in performance and scalability. The Redshift team examined our workloads and suggested the right cluster configuration. We use RA3 nodes that can scale storage and compute independently. They come with SSD storage. We also use concurrency scaling. the system automatically adjusts the compute based on the workload. During peak loads, we have seen as many as 10 concurrent clusters in use. That's the max limit. So this was valuable to us because we didn't have to provision hardware for the peak load. When we first started performance testing, the average response time was between 5 and 10 seconds. That was very far from where we wanted to be. So we realized we have a performance tuning journey ahead of us. So we wanted to build an automated program that can generate production quality workloads in our test environment. So we did two things with respect to this. First, we mined all the API logs from our on-prem application server and build a replay utility that calls those APIs against the cloud instance. Second, we use the simple replay utility provided by the Redshift team. Simple replay records and replays the workloads at database level. So combination of these two tools helped us create production quality workloads in our test environment. This was very helpful because we had to do multiple iterations of tuning and testing and deployment. First run query compilation is a very interesting one. We spent quite a bit of time here. Our application generates a lot of short dashboard type queries because customers slice and dice the data based on number of dimensions. So these short dashboard type queries incurred the first run compilation cost that run into several seconds. And it was hurting our SLAs. So the Redshift team partnered with us and provided enhancements that allowed to skip some of the segments of these short queries. So the first run compilation cost problem is solved. All the segments still go through the compilation in the background, so optimum execution happens in subsequent runs. So these enhancements has helped us come closer to the SLAs. SQL tuning, when we migrate from a row-based data warehouse to Redshift, there are several patterns of SQL that were not performing well. So the Redshift team identified them and helped us rewrite all those SQLs. Our solution architect has written a detailed blog I'll be happy to share with you. In addition to dashboard type queries, we also have reports. So these reports do not run very well on star schema. So we have denormalized some of the tables where there is high reports traffic. Finally, we've done a couple of things to prevent degradation of performance throughout the day. As I briefly shared, we run ETL multiple times throughout the day. So this causes significant number of updates and deletes hitting the data warehouse. In Redshift, a delete operation doesn't reclaim the space immediately, so we run vacuum multiple times, so the performance doesn't degrade. QMR, or query monitoring rules, is another interesting feature we use. From time to time, we see queries, ad hoc queries, that are not performing well on the cluster. They take up significant cluster resources and star the remaining queries. So we use query monitoring rules to identify such bad performing queries and terminate them. So a combination of all these techniques have helped us achieve the SLAs that I have shared. Our partnership with the Redshift team has been very broad. They've helped us from design, architecture, performance tuning, row-level security, and cost optimization. So the next item I'd like to talk is multi-tenancy. This is another important requirement for us. As a SaaS product with several thousand customers, our ask is to store multiple customers' data in one data warehouse. Also, one customer should see only their data. However, ETL jobs, because they are batch-oriented, they should be able to process multiple customers' data at the same time. So with these requirements in mind, we started looking at options in Redshift. We looked at two solutions, the bridge model and the pool model. The bridge model recommended one schema per client, so that was not scalable. And the pool model allows to store multiple customers' data in the same data warehouse, but still use access control restrictions to create these virtual boundaries for the customers. So how did we do this? Let's look at with the help of an example. We have employee table. It has multiple customers' data. So if customer 1 is executing this simple query, you're supposed to say only customer 1's data, right? So we use row-level security and session context variables to accomplish this. We enable RLS on this table and build an RLS policy with customer ID predicate. So at runtime, when a customer logs in, the first thing we do is set the session context variable with the customer ID value. Subsequently, any query that is executed by that customer will have the predicate attached to it. So the app developer doesn't have to attach the predicate. So this saves us from costly security incidents that may occur due to a developer error. From RLS perspective, we skipped or bypassed from ETL job perspective, we skipped or bypassed the RLS using role-based access privileges. Overall, from software engineering perspective, it was fairly easy to do this both from the application side and the data warehouse side. So a quick, in addition to scalability, performance, multi-tenancy, and data freshness, we realized several other benefits. We reduced our database footprint from several hundred databases to 5 Redshift clusters. Our support team says that they spend more time solving real customer problems and less time troubleshooting failed workloads. From cost perspective, we are saving about 30% of the cost because we migrated all our clients to cloud and sunset all our on-prem infrastructure. We also take advantage of map credits. During the migration phase, there is a period of time when we have both on-prem and cloud infrastructure. So the map credits help. And finally, it's easy to set up new environments. We recently spun up a Redshift cluster and the entire application setup in Europe, and we were able to do that within a couple of days. I would be lying if there are no challenges in this journey. There are quite a few challenges and learnings from those. Migrating 50,000 customers' data to cloud is challenging. It requires detailed planning and execution. So it is exciting to build a product in cloud, but we should keep thinking about migration from day one. The strategy we have taken is we grouped clients based on risk, usage patterns, and their profile, and migrated them in batches. Data quality is important. I can't emphasize how important it is. So before migrating clients, we have to make sure the quality of data in data warehouse is accurate. Let me give an example. Data warehouse doesn't enforce integrity constraints. So there's always a possibility that you end up with duplicates in data warehouse. So how do you find them, right? So you don't want the customers to log in and see all double values for their metrics and KPIs. So we built automated tools and process to identify data accuracy issues and fixed all those issues before we migrated the clients. Right-size the infra to optimize cost. So it's important to understand the various node types offered by Redshift and the pricing associated with it. The best practice we followed is start with the smallest node type and keep increasing it till you hit your desired performance levels. Train your team in cloud and Redshift skills, particularly performance tuning, architecture best practices, so they can manage the application in cloud. We also found that concurrency scaling, the concurrent cluster builds up its own cache, so the first few queries do have a cold start. As we move forward, we plan on optimizing our solution in cloud. We are planning to use zero ETL to replicate data from Aurora Postgres to Redshift. We are also exploring Redshift serverless to simplify management and further optimize cost. We're also looking at cross-region replication for disaster recovery. So I hope this session gave you a few ideas, and our learnings will be helpful to you. Thank you. Now I hand it off to Raza for his closing remarks.
Everyone, thank you so much for coming. For everyone who's starting new or planning your data warehouse modernization, I hope the information that Ravi and Sebastian provided you gave you real-world insights how customers are migrating and modernizing their data warehouse using Amazon Redshift. If you're just getting started or you're planning your data warehouse, we have the resources to help. We offer skills builder trainings, which give you the necessary skills to start building your modern data warehouse. We also help with executing detailed proof of concepts so that you can get your hands dirty with Amazon Redshift. As Ravi mentioned, the Migration Acceleration Program, or commonly known as the MAP program, offers credits to customers who start their migration journey with Amazon Redshift. Also, we also help, also with the program, we can assess, build future state architectures, and help you with the data warehouse migration using professional services or our trusted partners. Fun fact, I used to be part of professional services, and I've personally helped multiple different customers migrate or modernize their data warehouse with Amazon Redshift. So if you have any questions regarding the process or how to get a migration done end-to-end, please feel free to reach out to me after the session. We've put together a few resources here. If you want to learn more about customer success stories or the latest features of Amazon Redshift, or you just want to get started with Amazon Redshift, make sure to contact your account team for a 10 to 20-minute demo, or you'd reach out to your specialist solution architect so they can get you hands-on with Amazon Redshift with just a few clicks. If you're thinking of doing a data warehouse modernization or migration, please follow the links given on screen so we can start helping you out with the data warehouse modernization and migration. We have some exciting sessions lined up for you at reInvent. I know it is 5:30. It's 6:30, and everyone must be really tired. We really, really, really appreciate you sticking around and taking the time to listen to us and exciting stories from Ravi and Sebastian, who are our great customers who've modernized and migrated to Amazon Redshift. And you can take inspiration from these modernization and migration journeys to start your own migration and modernization journey. Please do fill out the survey for the session. And again, from Ravi, Sebastian, and myself, thank you so much for your time.